निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
In this session, we will be discussing the introduction part of exercise 2.2 of chapter 2 polynomials of class 10 NCERT mathematics. Here, we will develop a relationship between the zeros and coefficient of a polynomial. A relationship, there might be some relationship between the zeros and coefficients of any types of polynomials, maybe linear, maybe quadratic, maybe cubic. In our previous session, we have developed the relationship for the linear polynomial. The linear polynomial was given as p of x is equals to ax plus b, the standard form of the linear polynomial, where a is not equals to 0. And in order to find the value of x, that is, we need to find the 0 of the polynomial for which the polynomial becomes 0. And we used to get that 0 of the polynomial, that value of the x by the relation x is equals to minus b by a, and that is equals to minus constant by coefficient of x. Coefficient of x, we have taken this a to be coefficient of x. Coefficient of x means this all those values, all these constant values that are coming with the variable, that variable of the degree 1 for linear, that total value is said to be the coefficient of x. And that coefficient of x we are taking out here. X is equals to minus b by a, that is b was the constant term and a being the coefficient of the linear polynomial of the variable x. So the general formula can be written as x is equals to minus constant by coefficient of a. This x, the value of this x is the 0 of the polynomial. That means 0 of the polynomial can be written as 0 of p of x is equals to minus constant upon coefficient of x. Now, a relation has been developed between 0 of the polynomial and the coefficients that are present in the linear polynomial. This was for the linear polynomial x of degree 1, where there was only 1 0 of the polynomial. Moving on to our next polynomial, quadratic polynomial. Quadratic polynomial. P of x is equals to ax squared plus bx plus c, and a is not equal to 0. This was the condition given to us. From here, quadratic polynomial, let us show it once again, so that coefficients will also be identified from the polynomial. P of x is equals to ax squared plus bx plus c, and a is not equals to c. Now, observing this, as we have discussed in linear polynomial also, coefficient of the variable means that constant value which comes with that variable. Here, if you want to say coefficient of x squared, then what is coefficient of x squared? That constant value which is with the x squared. And what is that constant value here? That constant value is a. So coefficient of x squared is a. You can say coefficient of x. So what is the coefficient of x? That constant value that is with x. What is that constant value that is with x? That is b. So coefficient of x is b. Then what about this term? Well, there is no variable. We can see that can be termed as a constant term. There is no variable. Actually, there is variable, but that variable is of degree 0. So constant term can be considered, or coefficient of x of degree 0 can also be termed as c. These are the coefficients that can be taken. So coefficients of a polynomial can be taken as coefficients of x x square is equals to a, coefficient of x is equals to b, and the c was the constant term. Now in the quadratic polynomial, as we have discussed earlier, the highest degree of the x will give me the number of zeros that are possible for that polynomial. In quadratic polynomial, the highest degree of x is 2. So the number of zeros are 2. We can have maximum of 2 number of zeros. We can have 2 zeros. If we plot the graph, we have discussed earlier also, it will cut the x-axis or it will intersect the x-axis at 2 different points. If the number of zeros are 2, that means x will have 2 values. X will have 2 values, and at those 2 values, the polynomial becomes 0 if we put those values in the polynomial 1 by 1. X will have 2 values, 2 number of zeros. Say that 1 0 is alpha, the value of x is alpha, and the second value is beta. That means it has 2 zeros of a polynomial. Let that 0 be termed as alpha and the second 0 be termed as beta. Alpha and beta are the values of x for which the polynomial p of x becomes 0. That is why they are called the zeros of the polynomial. Now a relationship can be developed here as a sum of zeros. Sum of zeros, that means alpha plus beta. We have 2 zeros, one is alpha and the other is beta. So sum of zeros means alpha plus beta, and this is given as minus b upon a. Minus b upon a. And what is that? B. This is minus. B is coefficient of x upon coefficient of x squared. So this is a general relationship for sum of zeros for a quadratic polynomial, that sum of zeros is equals to alpha plus beta is equals to minus b by a. And what is that? Minus is as it is, and b is coefficient of x and a is coefficient of x squared. The second relationship that can be developed is product of zeros. Product of zeros. Product of zeros means alpha into beta, and this is given by c upon a. And what is c? C is the constant term that we have got from the polynomial. So this is equals to constant term or constant by coefficient of x squared. These are the two important relationships between the zeros of the polynomial and the coefficients of the polynomial for a quadratic polynomial. How we will have to do? Let us take an example. The question can move on this way. That find the zeros of the polynomial. Find the zeros of the polynomial. P of x is equals to x square plus 7x plus 10, and hence verify the relationship between the zeros and its coefficients. Between the zeros and the coefficients of p of x. Now we are given with a polynomial. The very first thing that we will have to do is find the zeros of the polynomial. First we will get two values of the quadratic polynomial that is given to us. P of x is equals to x square plus 7x plus 10. This is the polynomial given to us. the highest degree is 2. That means there are 2 number of zeros. That means the x can take 2 values for which the polynomial becomes zeros. Then what are the 2 values of x? First we will have to find. This can be solved by splitting it down. X square plus 5x plus 2x plus 10. We take x common, x plus 5, we take 2 common, x plus 5, and this is x plus 2 and x plus 5. These are the 2 factors that we have here for the polynomials, and from these 2 factors we will get the 2 zeros of the polynomial. In order to become the polynomial to be 0, either of these would be 0. If this is 0, then the polynomial is 0, or if this is 0, then the polynomial is 0. So if x plus 2 is equals to 0, x is equals to minus 2, or if x plus 5 is equals to 0, so x is equals to minus 5. So we have got 2 values of x. X is equals to minus 2 and x is equals to minus 5. So these are the 2 values of x for which the polynomial becomes 0. That means these are called the zeros of the polynomial. Let us consider each 0 to be alpha. Let this be alpha and let this be beta. Now we need to verify the relationship between the zeros and the coefficients of the p of x. We have got the zeros alpha and beta, and we have 2 relationships for quadratic polynomials that we have seen that alpha plus beta is minus b by a. That is sum of the zeros is equal to minus coefficient of x by coefficient of x square. So we need to verify. So let us first verify sum of zeros, that is alpha plus beta. And what was alpha? Alpha was minus 2. What is beta? Plus minus 5. So this becomes minus 7. If this is minus 7, this can be written as minus 7 upon 1 if we observe there. If we don't want to do it directly, then also there is another way. But this is very easiest way because the coefficient of x square is 1. So we can consider out here 1. And what is minus 7? This is minus b upon a, and this is minus coefficient of x upon coefficient of x square. Now so you see it has been verified. Sum of the zeros, that is alpha plus beta, minus 2 minus 5, total becomes minus 7. And if you want to find or compare this minus 7 with the standard form of quadratic polynomial ax square plus bx plus c, then you can see that this 7 is the coefficient of x and this one is the coefficient of x square, and thus we can write this is minus b by a, and that is equals to minus coefficient of x by coefficient of x square. One more is left out, product of zeros. Product of zeros, that is alpha into beta. This is minus 2 into minus 5, and this is equals to 10. Then again, if we compare it with the standard form, we have the constant term to be 10, so the denominator can be 1, and we can write this one as c upon a, and this is constant term upon coefficient of x. You can verify this way also. The other way is you can verify the LHS and RHS also if you want. The LHS can be taken from the zeros of the polynomial that we have calculated, and the RHS part, that is minus b by a, can be directly taken from the polynomial, and comparing both you will be getting the values to be both same or equal. Then also you can verify. So there are 2 different methods of verification: directly moving this way or moving separately by solving separately the LHS and RHS and making them equal, comparing them in the standard form of the quadratic polynomial. Next we will be moving with example number 4. the previous one that we have done was example number 2, and example number 3 is left for you for practice purpose. So kindly go through your NCERT textbook and solve example number 3 of chapter 2, polynomials. Find a quadratic polynomial, the sum and product of whose zeros are -3 and 2. Now we are given with the sum of the zeros -3 and the product of the zeros 2. In the previous questions, we were given with the polynomials and we were finding the zeros of the polynomial, and then we were verifying the sum of zeros and product of zeros. Now here it's a vice versa. Now you are given with the sum of the zeros and the product of the zeros, and you have to find the quadratic polynomial. Moving on with the same formulas that we have, sum of zeros, that means this is alpha plus beta and this is alpha into beta. Let us move on with one by one. Alpha plus beta is equals to -3, and we know alpha plus beta is -b by 2. If you solve this part, this much part, you get b equals to 3e, and alpha into beta is, we have 2, and this is c by a, and if you solve this part, you get c equals to 2. Now the values of b and c are dependent on the values of a. We have the standard form of quadratic polynomial, p of x is equals to ax squared plus bx plus c. This is the standard form that we have. If we take a equals to 1, suppose we take a equals to 1. If a equals to 1, then b will be 3. If you substitute the value of a here, it becomes 3, and c will be 2. So c is equals to 2. Now the polynomial that we will have is p of x is equals to, if you substitute these values in the standard form, you have the polynomial x squared plus 3x plus 2. Well, we have taken the value of a to be 1. If a is equals to 2, suppose we change the value of a, then b becomes 3 2s are 6 and c becomes 2 2s are 4. Now you will have new polynomial p of x is equals to 2x squared plus 6x plus 4. You can now take a equals to 3. The number of times you change the value of a, you will get that number of quadratic polynomials, and each one is related to the other. Suppose you see this one, if you take out 2 common here, just you will get the same as this one with a multiple of 2. That means the coefficients are just the doubles. That means the changing of value of a will give me a new polynomial. So in general we can say if a changes k times, then the standard polynomial that we require would be p of x is equals to k times of x squared plus 3x plus 2. This will be our required polynomial that completely depends upon the values of a that is changing continuously, either 1, if you take 2, if you take 3, if you take k, then it becomes k times of x squared plus 3x plus 2. So this is one method of obtaining the quadratic polynomial when sum and product of zeros are given to us. There is another method also, that is what we call as alternative method. Alternative method. In the alternative method, we have been given directly with the formula, and the formula for the required polynomial is p of x is equals to k times of x squared minus sum of zeros to x plus product of zeros. This is the general formula for finding the quadratic polynomial when sum of zeros and product of zeros are given to us. Now, when sum of zeros and product of zeros are given to us. So let us try that with the same example. Are we getting the same polynomial with an alternative method? Let us move on. Here, the required polynomial is p of x, and that is equals to a times of x square minus the sum of zeros alpha plus beta was given to us as minus 3. So let us take this one as minus p of x, and then we need the product of the zeros, and the product of the zeros is given to us as 2. So you can write alpha into beta is equals to 2, and solving you can get x square plus 3x plus 2. If you compare the polynomials with two different methods, one a general method and second using direct and alternative method using the formula, we get the same quadratic polynomial. So this is the method to find a quadratic polynomial when sum of zeros and product of zeros are given to us. Relationship between zeros and coefficients of a polynomial. We have gone through linear polynomial, we have gone through quadratic polynomial. Now we will be moving with cubic polynomial. And now we will be restricting ourselves till cubic polynomial only, because polynomials above degree 3 are not in your class 10 syllabus. That you will be going through in your higher classes. We will be restricted to a polynomial with degree 3. That is what we call it as a cubic polynomial. Again, zeros of a cubic polynomial. Zeros, as we have discussed earlier also, the highest degree of the x will give me the number of zeros that are possible in a polynomial. Here we are taking cubic polynomial. The cubic word itself gives me that the degree of x is 3, and that is given by the standard form p of x is equals to ax cubed plus bx squared plus cx plus d, where a is not equals to 0, and the highest degree of x is 3, so there are 3 number of zeros. That means the x can take 3 values. X will have 3 values, for which values the polynomial becomes 0. Or those values where the polynomial becomes 0 for the values of x, such values are called by zeros of the polynomial. 3 in numbers for cubic polynomial. Then what regarding coefficients? Because we need to relate the zeros of our polynomial with the coefficients of the same polynomial. Here, as discussed in quadratic polynomial also, we can say coefficient of x cubed. That means that constant value which comes with x cubed. So here that value is a. So coefficient of x cubed is a. Then coefficient of x squared is that constant value that comes with x squared, and that value is b. Then coefficient of x means that constant value that is with the variable x, and here it is c, and d, that is a constant. So this is constant value is equals to d. Now these coefficients can be related to the zeros of the cubic polynomial, which are 3 in numbers. Here the zeros are 3 in numbers. That means x has 3 different values. Suppose those values be, say, x is equals to alpha, x is equals to beta, and x is equals to gamma. Let us take these 3 values for x. That means at x is equals to alpha, the polynomial becomes 0. At x is equals to beta, the polynomial becomes 0. And at x is equals to gamma, the polynomial becomes 0. Now we need to develop the relationship between the zeros and the coefficients of a cubic polynomial, taking each zero at a time. That means we can take each zero, say alpha plus beta plus gamma. That means these are the sum of zeros, what we call it as sum of zeros. Is alpha plus beta plus gamma, and this is given by the relation minus b upon a. That means this is minus coefficient of x square upon coefficient of x cube. This is the relationship between the sum of zeros and the coefficients of a cubic polynomial. Now, second, taking two at a time, two zeros at a time. That means sum of the zeros taken two at a time. That means you can say alpha into beta plus beta into gamma plus alpha into gamma. Here we have taken two zeros at a time, two zeros at a time, two different zeros at a time and their sum. This is given by the relation C upon A. C upon A. What is C? C is coefficient of x upon coefficient of x cube. Now taking 3 at a time, what we call it as a product of zeros. This is product of zeros. Taking all the 3 at a time, alpha into beta into gamma, and this is given by the relation minus d upon a. And what was d? This is minus constant term upon coefficient of x cube. So these are the relationships for a cubic polynomial between the zeros and coefficients. The zeros, that is sum of zeros taken one at a time, that is minus b by a, or you can say minus coefficient of x square by coefficient of x cube, taken two at a time, alpha beta plus beta gamma plus alpha gamma is c upon a, that is coefficient of x upon coefficient of x cube, and product of zeros, that is taken 3 at a time, alpha into beta into gamma is minus b upon a, where d was the constant term and a is the coefficient of x cube. Moving on to the example of a cubic polynomial, we will be discussing example number 5 from NCERT textbook, chapter 2. There we are given in the polynomial p of x is equal to 3x cube minus 5x square minus 11x minus 3. And we have to verify that 3, 1 and minus 1 by 3 are the zeros of that polynomial. Furthermore, we have to verify the relationship between zeros and coefficients. Now, let us move on to the first part. We have to verify that 3, 1 and minus 1 by 3 are the zeros of the polynomial. What do we mean by zeros of the polynomial? As we have discussed, if you substitute these values here in place of x, the polynomial becomes 0. So you can verify putting x equals to 3 in the given polynomial, you will get the value of px to be 0. You can put x is equals to 1 in the given polynomial, you will be getting the value as 0. If you substitute minus 1 by 3 in the polynomial, you will be getting the value to be 0. This you can do as you have done in class 9 also. Just you have to substitute the value and verify that the polynomial becomes 0 at these 3 values of x, that means at 3 zeros of the polynomial. Now we can say that these 3 values of x which makes the polynomial 0 are the 3 zeros of the polynomial. So we can say that you can do it by yourself. I will be solving the next part. Verify the relationship between the zeros and these coefficients. You can check that these are the zeros by yourself. After checking, we will be verifying the relationship between the zeros and coefficients, and let us continue with that. If these 3 are the zeros of the polynomial, let my first zero be alpha is equals to 3. The second zero, beta is equals to 1. And the third zero, gamma is equals to minus 1 by 3. We need to verify the relationship between the zeros and coefficients for a cubic polynomial whose relationship is given here. We just need to verify that we had discussed earlier. So sum of zeros that we call it as alpha plus beta plus gamma. All the zeros taken one at a time. The sum of zeros, this can be taken as alpha is equals to 3, beta is 1 and gamma is minus 1 by 3. And if you solve it, this becomes, if you take the LCM 3, then 9 plus 3 minus 1, and this becomes 9 plus 3, 12, 12 minus 1, 11, 11 upon 3. And if you compare it with the the standard form of the polynomial. The standard form of the polynomial is ax cubed plus bx squared plus cx plus d. And if you observe there, this is 3 is 9, 4 is 12, this is alpha, beta, and gamma. Let me check out. You are not getting that. Yes, that was my mistake. The value is -1. So this will be -1, and this is also -1, and this is also -1. So this will be getting as 5/3, and this could be written as minus of -5/3 as to obtain minus b by a. If you compare there, this is minus b upon a, and this is minus coefficient of x squared upon coefficient of x cubed. The first is to verify. It was a mistake in copying down the question from the textbook. That was in place of -1, it was written 1, so kindly consider it. The second we will be doing is alpha beta plus beta gamma plus alpha into gamma, that is we will multiply 2 at a time. So alpha into beta, so 3 into -1 plus beta into gamma, -1 into -1/3, -1 into -1/3, and third alpha into beta, that is 3 into alpha into gamma, that is 3 into -1/3. Multiply 3 into -1 is -3 plus 1/3, and it is cancels -1. So this is -4 plus 1/3. To take the LCM, this is 3 minus 12 plus 1. So this is equals to minus 11 upon 3. And if you compare with the standard form of the cubic polynomial, that minus 11 is the value of c. So this can be written as c upon a, and then c upon a is coefficient of x upon coefficient of x cubed. So this is also verified. The second is also verified. Now the product of the zeros, taking 3 at a time, alpha into beta into gamma. So this is 3 into -1 into -1/3, and this cancels, and this is -1 into -1 is +1. And if you need to arrange this in the form of b by a, that to minus b by a, so we can arrange this one as you can multiply 3 and you can multiply 3 in the denominator to show exactly what is b and what is a, or else you can directly would have calculated b by a and substituted there. But we are exactly moving with the standard form. So here also we have 3, here also we have 3. 3 upon 3 is more than we know. So this can be written as 3 upon 3, and if you make it in the standard form, take minus sign common, and you can write this way, and this becomes minus b upon a, and this is constant term. This is minus of constant term upon coefficient of x cubed. So now all the 3 relationships for a cubic polynomial, that is sum of zeros taken 1 at a time, then sum of the zeros taken 2 at a time, and the product of zeros that is taken 3 at a time, has been verified for the given polynomial. So we can write hence verified. So the question is, you have to verify the zeros of the polynomial, that these are the zeros, and then you have to verify the relationship between the zeros and its coefficients. This you have verified, and we have verified the relationship between the zeros and its coefficient in all the 3 ways that we have discussed, and finally on reaching hence verified. Exercise 2.2. Question number 1. Find the zeros of the following quadratic polynomials and hence verify and the coefficients. This type of question we have done in our example also. There are 6 bits to the question. I'll be solving 2 and the rest 4 are for practice purpose. Because solving all the questions, you won't find it, just sit down and try. So, we will be solving the 2 and the rest 4 are for you, for practicing. The first polynomial that is we are given for it will be solving with 3, p of x is equal to 6x square minus 3 minus 7x. The very first thing is we need to find the zeros of the polynomial, and then we will have to verify the relationship between zeros and coefficients. So we need to find the zeros from here. If we observe the polynomial is not in the decreasing order of the degree of x. That means it is not presently in its standard form. So we will have to change it in its standard form. So this is 6x squared, then degree 2, then degree 1, this is minus 7x, and then minus 3. We need to find the zeros for it. That means we will have to find those values of x for which the polynomial becomes 0. So let us move forward. P of x is equal to 6x squared minus 7x minus 3. By applying splitting Middleton rule, this can be written as 6x squared minus 9x plus 2x minus 3. Taking 2 at a time, we can take 3x, and this is 2x minus 3 plus 1, and this is 2x minus 3, and you will get the factors as 3x plus 1 and 2x minus 2. These are the 2 factors of the polynomial p of x. But we need values of x which will make the polynomial 0, so that we can say that those values are the zeros of the polynomial. That means in order to make the polynomial to be 0, either of these two should be 0. If this is 0, if 3x plus 1 is equal to 0, then we will have x is equal to minus 1 upon 3, and if 2x minus 3 is equal to 0, then we will have x is equal to 3 upon 2. So these two values are those values which will make the polynomial to be 0, and hence can be considered as the zeros of the polynomial, that is minus 1 by 3 and 3 by 2 are the zeros of the polynomial, are the zeros of p of x. So we have got now the 2 zeros of the polynomial, and now we have to verify the relationship between the zeros and the coefficients. So since 2 zeros are there, we can take the first value, say alpha, the first zero, as minus 1 by 3, and beta is equal to 3 upon 2, and we will have to verify the relationships. And what were the relationship? That was alpha plus beta, that is sum of zeros, is equals to minus coefficient of x by coefficient of x squared, that is alpha plus beta is equals to minus b by a. So let us do first. Alpha plus beta, that is sum of zeros, is minus 1 by 3 plus 3 by 2. Solving by taking the LCM, this is 6, this is minus 2 plus 9, and this is minus 7 by 6. Is it minus 7 by 6? This is plus 7 by 6, which can be written as minus of minus 7 by 6, keeping this minus as it is, and minus 7, comparing by the standard form of the quadratic polynomial ax squared plus bx plus c. You see the value of b is minus 7, so we can say this is minus coefficient of x upon the 6 is the coefficient of x squared, so this is coefficient of x squared. So we have got sum of zeros, that is alpha plus beta, is minus coefficient of x by coefficient of x squared. Now we will be moving on to the next product of the zeros, that is alpha into beta. So alpha was minus 1 upon 3 into 3 upon 2. If you solve it, this is cancelled, this is minus 1 upon 2. And we need it in the form of c by a. What is c here? This is minus 3, but we don't have minus 3 there. So let us arrange it. Multiply here 3 and multiply here 3. You can get this one as minus 3 upon 6. Now you got that is C. This is C is minus 3 and that 6 is the coefficient of x square. So you can have to just write this is equals to constant upon coefficient of x square and hence verified. Moving on to the next bit, same way as we have done earlier. First we will have to find the zeros of the polynomial and then we will have to verify the zeros with its coefficients. Now this is the polynomial e of t is equals to t square minus 15. Here the middle term is missing. If you see, there is no t term, that is the variable t with degree 1. So this can be solved by the identity a square minus b square is a minus b into a plus b. This is possible to solve by this way. So this can be written as b square minus root under 15 whole square, and this can be written as t minus root under 15 and t plus root under 15. These are the two factors of the given polynomial with variable t. For the polynomial p of t to be 0, again either this have to be 0 or this have to be 0. That means we will get two values of t for which the polynomial pt becomes 0 and those two values of t will be my zeros of the polynomial. So for p of t is equals to 0, either t minus root 15 is equals to 0 or t plus root 15 is equals to 0. Either of the two should be 0. So if this is 0, then from here we can get the value of t to be root under 15, or this is 0, we can get the value of t from root under 15. Now we have got the two zeros and we will have to just verify the relationship between the zeros and the coefficients. Alpha is equals to root under 15 and beta is equals to minus root under 15. So we have got two zeros and we will have to just verify. So let us verify sum of zeros, that is alpha plus beta is equals to root under 15 plus minus root under 15 and this is equals to 0. 0 and we know alpha plus beta should be minus b by a from our relationship. But there is no b term out here. We know that there was no middle term b. So this would have been written as 0 upon 1 and 0 is minus coefficient of x upon coefficient of x square. But here our variable is t. So we have to write coefficient of t upon coefficient of t square. From where did we get b is equals to 0? Comparing this polynomial with the standard form ax square plus bx plus c. There was no middle term in terms of b, so b was considered to be 0. Then the product of 0, that is alpha into beta. Root under 15 into minus root under 15 is minus 15. This would have been written as minus 15 upon 1. And what is minus 15 comparing with the standard form? That is my constant term and the 1 is the coefficient of t square. So this is equals to constant term upon coefficient of t square. Hence, verified. Number 2. Find a quadratic polynomial, sum and product of whose zeros are given as. Here also we have 5 bits. I'll be doing 2 for you and 3 are for your practice. I'll be doing bit 2 and bit 5. Let us move again back to the question. Sum and product of zeros are given to us and we need to find a quadratic polynomial. That means we are given here as alpha plus beta is root under 2 and alpha into beta is 1 over. We have 2 methods for finding the polynomial. We will be moving with the easiest method, that is the alternative method that we have discussed. The required quadratic polynomial is always given by the form k into x square minus sum of zeros product of zeros. Or this can be written as a into x square minus alpha plus beta into x plus alpha into beta. We just need to substitute the values of sum of zeros and the product of zeros and have to solve it. This is k into x square minus alpha plus beta. We had root 2x plus alpha into beta is 1 upon 3. Trying to convert it to standard form. Let us take the LCM here and we can solve 3. So this can be written as 3x square minus 3 root 2x plus 1. If we move this 3 outside, this is k by 3 and this is 3x square minus 3 root 2x plus 1. And writing, since k is also a constant, so k by 3 will also be a constant. So you can replace this k by 3 with k. So this is the standard form that we have got in the form of ax square plus bx plus c, and this is the required polynomial that we are getting when sum of zeros and product of zeros are given to us by alternative method, which I told you is the most easiest method. Moving on to bit 5. Here also we are given as sum of zeros as 1 by 4 and product of zeros as 1 by 4. Sum of zeros is minus 1 by 4 and product of zeros is 1 by 4. So the required polynomial that we need is p of x is equal to k into x square minus alpha plus beta into x plus alpha into beta. Just we have to substitute the sum of zeros and product of zeros here and solve it. So this is k x square minus 1 by 4 x plus 1 by 4, and you have to solve it just. So this is k x square minus into minus plus, this is 1 by 4 x plus 1 by 4, and taking the LCM inside the bracket part, you can have k into 4x square plus x plus 1. And if you take this denominator to be the outside with the constant value, it becomes k upon 4, and this is 4x square plus x plus 1. K was a constant, and it is divisible by 4, that will also be a constant. So if you want to replace it, you can replace it as this way, k into 4x square plus x plus 1, and this is our required quadratic polynomial when sum of zeros and product of zeros are